Hi friends, today I am here to teach you the Matlab code for Gauss elimination method. Gauss elimination method is one of the various methods we use to find the solution for simultaneous equations. That is, you are given two equations with say 2 or 3 variables. For example, x plus y plus z is equal to something. So this is an equation. Another equation like this, and you have to solve both of these equations. That is known as simultaneous equations. One method to solve such equations is Gauss elimination method. Normally in the question we have two equations. What we do is form a matrix, two matrix, and then solve the equations. So first of all, as we can see here, n is enter the number of square matrix n. What they're asking me here is how many equations are given. So you enter 3 or 2, whatever, depends on the number of equations that is given. So first I have to feed the value n, that is the number of equations. Then we come to this loop in which we have I is equal to 1 to n, j is equal to 1 to n. Now why we are doing this? We have to form the matrix of the equations. So for that we have I as the number of rows and j as the number of columns. So we have to repeat this loop till n number of times, that is if 3 equations are given, then 3 times, so that we can form the matrix A R I comma j. So this loop from here till here gives us the first matrix. Now then after this, in the equation we have x plus y plus z is equal to 6, then 2x plus 3y plus z is equal to 8. So is equal to, after the equal to sign we have 6 and 8. So we form another matrix for the terms after the equal to sign. So for that we have this loop. For I is equal to 1 to n, printf enter the value of the new matrix which we have called AR1 I, and we just have row in this, one row, because 6, 8, 4 equal to, after equal to we will have just one value, so we form a row matrix in it. So this is the second matrix. So from here to here what we have done is form two matrices. After this we come to this loop. Now what do we do after forming the matrix? We ensure that all the diagonal elements are 1 and we form a lower triangular matrix, that is the lower portion should have 0. So here we are ensuring that the first term of the first matrix becomes 1. So we take the element here, you can say D is equal to AR I comma I. I comma I will be the value of the diagonal elements 1, 1, 2, 2, 3, 3. So we are dividing all the elements of the matrix with the diagonal element. As you can see here, it is ARIJ is being divided by D, that is the diagonal element. So this ensures that the diagonal elements becomes 1. So once it is 1, we can multiply it with a value s. Once we multiply the diagonal element with a value s and then we subtract that, we will find that we form a lower triangular matrix, that is all the values become 0. So till here what we have ensured is that the values are becoming 0. We do the same operation for the second matrix, that is the row matrix. We have to subtract, multiply s into it and then subtract it. So all the operations that has been performed in this matrix should be performed in this matrix as well. Now we come to the part in which we have to do backward substitution. The last column of the matrix would look like 0, 0, 1 is equal to 6. So we have to write z is equal to 6. And now that we know the value of z, we then do backward substitution, put the value of z in the second equation. Then we find the value of y, and then now we know xz, yz. So now then we can again find x by putting the values of y and z in the first equation. So this part of the code is for backward substitution, in which we are taking an is equal to ar1 and then we take w, then we take this loop which is basically for backward substitution, and then as and when we have done this we print the value. Now printf is the value of x percentage d is equal to percentage f. Now what is this percentage f? Where is it stored? This is aj. It is stored in aj. So we write j comma aj and then we end it. After every for loop you have to end it, and the statement after the for does not have a semicolon. We can see in rest all these statements we have to put semicolon, not in front of the statement after for. Now we'll see the output of this. So now they're asking me how many equations are there. Say we have 2 equations. So now enter the value of the first element, 1. Now they are asking me the elements of the matrix that is formed when we put the values after the equal to sign. So let it be 2 and 2. So now we get the values of x and y. So this was an easy tutorial for Gauss elimination method. The next method that I'll be teaching you is Gauss-Seidel, which is again another method to solve simultaneous equations. Thank you.